All right, hello, good afternoon. My name is Kyle. I'm the founder and the chief product officer of Bigeye. Bigeye is a data observability platform. We're the leading observability platform for the enterprise segment. And today I'm going to be talking to you about the past, the present, and the future of how AI and data observability work together. So a year ago, I was here at Big Data London, and I was announcing the availability of our end-to-end data lineage product. Today we offer lineage. So a year ago, I was here to announce the availability of our end-to-end data lineage product. I'm very happy to say that just 1 year later, we are now tracing over 100 million lineage connections for our customers in both the US Fortune 500 as well as the FTSE 100. So very exciting development since just a year ago when we were last here. So I wanted to take a moment to celebrate that milestone that we reached before heading into today's agenda. So the talk will be broken down into 3 sections. The first is about the past of how AI has been used in the data observability space. So this is primarily in the world of embedding AI into data observability. So we'll look at some ways that's been done. The second section will be about how we're leveraging AI today. And so this is largely about the use of agentic AI and how we can start to leverage agents in the world of data observability. And then the third section will be about the future. So this will be looking forward to how data observability, rather than leveraging AI, can be used to support AI and help ensure the trustworthiness of AI when it's deployed in an enterprise environment. So let's start with the past. So embedding AI into data observability products. So in Gartner's market guide on data observability that I think was released almost 2 years ago now, a year and a half, they specifically called out the capability to identify root causes of data quality issues, as well as recommend resolutions to those problems at the time as an advanced capability for data observability solutions. It was a fairly rare thing for the platforms to be able, not just to be able to point out where in your data pipelines problems were happening, but to help you understand how you could actually go about fixing them. Now, the reason that this particular part of the data observability puzzle is so valuable to solve becomes very clear when you look at what analytics downtime might look like for one of the average companies in the FTSE 100. So the average income or the average annual revenue for the FTSE 100 is around 18 billion pounds per year. So that works out to just under 70 million pounds per day. Let's say conservatively that they have around 1,000 dashboards at the company that are actually used for day-to-day decision making. These are important in actually operating the business. So that works out to just under 70,000 pounds per day that each dashboard is helping the business make decisions on. So that means that each minute of downtime, if you take 1,440 minutes in a day, every minute that one of those dashboards is not usable, it's missing data, the data is inaccurate, we don't trust the data, that's 48 pounds per minute that's costing the company. Every single minute that goes by that dashboard is not usable. So if we're able to use data observability to reduce the amount of time it takes to solve a problem that affects any one of those dashboards by just 10 minutes on average, multiply that by 1,800 issues per year that you experience across the enterprise, that's the average for Bigeye's customer base. So in every 12 months, we identify around 1,800 data quality problems for our customers automatically. That's a savings of 846,000 pounds per year if you can find a way to help a data engineer cut the amount of time it takes to fix a data quality problem by just 10 minutes on average. So this is why Gartner highlighted that capability in the market guide, and this is also where we decided to apply AI inside of our data observability platform earlier this year. So we call that application Bigeye, and this refers to us using LLMs inside of the product. So this is not observing AI in some fashion, it's using it inside of the platform to help accelerate the amount of time it takes to solve a data quality problem. Now, how did we do that? The first step is just describing what's going on inside of a data pipeline. So when we flag a problem, we actually use traditional machine learning models to identify data quality issues initially. So this could be something like an ETL job is not running when it should be. We see duplicate rows in a database. It could be that we see a sudden change in a distribution inside of the data. So we use traditional machine learning models to identify those problems, but then once we've identified the issue, we still need to pass it to a human data engineer so that they can go and actually fix the problem. So when we do that, we use LLMs to summarize all the metadata that we have about the state of their system and the problem that we've identified. So that could be things like, when did the problem occur? Where in the pipeline did it occur? What do we see downstream from the issue along the pipeline? So if we see that the problem happened with an ETL that loads data from a transactional database into a data warehouse, and we see that downstream that data warehouse is feeding a few Tableau reports, it's feeding a few Power BI reports, we can summarize all that information automatically so that when the data engineer is looking at this alert that they're receiving, they have the full context about what's going on in their system in plain English. So this is one step in optimizing the response time in solving a data quality issue. So this gets us through some of our 10-minute reduction that we were aiming for. The next is in recommending resolution steps. So normally an engineer has to take the information that they're receiving about what the problem is. Okay, I see that it's happening with this Informatica Power Center job. I see that that job had a change made to it yesterday. The job ran last night, then suddenly we had the issue. Therefore, it might be the Informatica job, and I need to go and actually read that job and understand what's going on. Maybe somebody introduced a bug. With Bigeye, what we can do is we can actually analyze all that information for the engineer and automatically generate recommended solutions for them. So we're able to do this in a few different ways. One is we look at the history of the issues that have been solved in the past. So if Bigeye's been in use at a customer environment for 2 years, we have quite a period of time where they've been solving issues, and we've been recording those notes that they keep as they go through the incident management process, and all of that is context that we can feed to the model to help inform the data engineer who's now dealing with a similar issue today and about what they should be doing. The second piece of input we give to the LLM when we generate these recommendations is we actually run queries on the impacted data. So let's say that you have a customer table in Snowflake, that's where we've detected an anomaly. What we can do is we can actually pull a sample of the impacted records out of that table and then give them to the LLM and ask it to look for outliers or patterns or other sort of explanatory factors that might help understand what looks weird in the data that is impacted by the anomaly, and that might also help identify solutions. And then another piece of input that we can give it is we can actually, because we are tracing that lineage that I talked about at the beginning of the talk, we have access to the code that is running in all of the ETL platforms along the pipeline, and we can feed that code to the LLM and we can ask it to look for potential bugs in the code as well. So we take all those steps, we put it all together, we hit an LLM with all that information, and we ask it to recommend potential solutions for the data engineer to take. So what this could do is it could shortcut that process of having to think about what do I need to go and look at in my infrastructure, or what actions do I need to take to fix the problem itself. Third, we tried to actually prevent issues in the first place. So I challenged our engineering team to say, if we can not just help a customer fix problems that we've already identified, if we can actually help them prevent a problem from happening in the first place, what would that look like? So somebody on our team identified, again, this the fact that we can consume the code that's running in the ETL platform. And so what we can do is when a data engineer is looking at their pipeline, we can actually show them potential improvements to make to the steps in the pipeline. So each of those ETL jobs, we can recommend performance improvements. We can identify potential problems or bugs in the ETL jobs themselves. And we can also help them with defensive coding measures. So for example, there might be a situation where as long as we don't have any null values in a field, the job is going to run fine, but it doesn't have any way of preventing the job from producing bad outputs if we do have a null. So we can recommend a defensive adjustment to the code that allows that job to run smoothly or gracefully even with the introduction of null values. So this actually helps us prevent issues from occurring in the first place because we can help a customer make their entire pipeline more robust to different types of problems that could occur in the future. So these are just some examples of what I view as the past of the interaction between AI and data observability, in that this is using AI embedded inside of an observability product to help make it better at what it already does. So next, let's talk about the present. So I'm sure everybody's heard about agents and agentic AI at this point. Now the question is, how can we leverage agents in a data observability context, and what do we need to actually do to make that work? So fortunately, last year, Anthropic debuted Model Context Protocol. It was then also supported by OpenAI, which makes it as close as we're going to get right now to an industry standard. And MCP allows for an agent or an LLM to start to interface with things like APIs or databases, because it gives them a sort of a USB port, if you will, for interoperating with these different systems. And so what it does is it exposes in English to an LLM the ability to make an API call or query a data store. And so what that allows us to do now is start to take agents. Let's use Claude Desktop as an example, where I can ask Claude to do something for me, and it has the ability to reason about what to do. And this now gives it the tools to actually connect to systems and go and do that work for me. So here's an example. We have a user. The user wants to know, how's my data quality today? And they could go and log into Bigeye. Bigeye's connected to all their different data systems. They can go and look at their dashboard and see what is the overall health of things right now. They could see if they have any notifications about issues that they might need to fix. So that's a human being going to a UI, logging in, looking at the screen, clicking around, that kind of thing. Now, what would this look like if we made this agentic instead and we had an agent do this for us? Now what we do is, instead of the human being logging into the UI and looking at it themselves, what they can do is they can communicate with an agent instead and say, I'd like you to tell me how my data quality is. That agent can then connect to the MCP server, and the MCP server exposes to the agent a series of tools that are specific to Bigeye that agent will now know how to use. So things like, tell me the health of a table, or tell me about the issues that are currently open in the system that need to be checked by an engineer. Or get those recommended resolutions that I talked about in the previous section. So those are all tools that an MCP server can expose to the agent to take. Now, to the agent, it looks like English, and to Bigeye, it looks like API calls, and that's the magic of MCP. So I can actually show you a demo of this right now. So here we have Claude Desktop, and I'm just going to ask it, how's my data quality today? And so now this is being sent off to the LLM. The LLM is going to interpret my question. It's going to connect to the MCP server that I have running here. And so first what it's doing is it's accessing the list of potential tools that it has to work with. It's using the get issues tool. So it's actually now making an API call to Bigeye and fetching the list of currently open data quality issues that we've identified in the demo environment. And now the LLM is summarizing for me what it's seeing. So again, I'm not logging into a UI. I don't need to click around. I just fire off a query and I let the agent do the work for me. So it's summarizing for me the priority of the issues that it's identifying. And then it's even doing some analysis for me. So this here about patterns and themes, this is not something that Bigeye does. This is being done by the agent on my behalf. It's interpreting the intent of my question, and then it's using the tools available in the MCP server to try to answer it for me. And then here it's recommending actions for me to take next. So this is starting to use an agent to do the work for me of interacting with the existing data observability tool. So this is kind of the stage that we're in today, is many companies are starting to introduce agentic workflows into their products, and this is, I view, as sort of the stage that we're in now. Previously, we were embedding the AI directly as features into the tool. Now we're starting to use AI as agents that operate on our behalf and can leverage the tools for us without us having to do the work ourselves. Next, let's talk about the future. So we've looked at using AI in a couple different forms, either as a way of accelerating data observability or even just doing some of the work on our behalf. But this led to us flipping the question and asking instead, how can data observability assist with the deployment of AI in other environments? And I view this as kind of where this industry is headed next. So let's take a look at what that could look like. So the first thing to know is that enterprises are starting to adopt agentic AI through platforms. So in the very early days, let's say a year ago, 18 months ago, you had teams of engineers that were part of leadership-driven initiatives that would be custom building agents. They'd be using Vertex or Bedrock or something like that. They'd be building an agent from scratch as a prototype. They would show off that it could do something and try to get funding to continue their AI initiative. But increasingly what we're seeing is that the major players like IBM, Salesforce, Microsoft, they're just rolling out platforms that make the process of deploying an agent much easier, more turnkey, more repeatable. And so we're already rapidly moving away from completely bespoke agents, and we're moving towards a world of platforms. All of the agents that get built on those platforms, though, in order to do their work, are going to need to connect to enterprise data sources. So that means ADLS. They need to be able to query Snowflake. They might need to be able to pull files out of SharePoint. And at any decently sized enterprise, you're going to have a wide variety of the agentic AI platforms. You have Salesforce Agentforce over here. You have Microsoft Copilot Studio over there. And then you're also going to have a variety of data stores underneath. So you're going to end up with this sort of spider webbing between your agents and all of your data sources. And this introduces a question, which is, how do we know what data all those agents are accessing? Should they have permission to access it? How high quality is the data that they're touching? Does it contain sensitive information? How do I manage all of this as we start to roll out? So these are three of the big categories that I would view as key questions we have to ask about whether or not we can trust the AI that we're rolling out when it gets access to our enterprise data. So the first is data quality. So if I have an agent, let's say it's a customer support agent, and you're going to ask it, hey, I placed an order, the order hasn't arrived yet, what's going on? That agent is going to need to be able to go and query a table out of Snowflake, formulate the answer, give it to the customer. If that data that it's accessing in Snowflake is either delayed or duplicated or has some other sort of an issue, the LLM is not necessarily going to know that. It's just going to summarize the data that's in that table and tell the customer what the answer was. So data quality now becomes really critical, especially because LLMs don't have judgment the way that human beings do. So that's the first sort of category that we need to be able to monitor if we're going to trust AI as we roll it out. The second is sensitivity. So PII, PHI, these types of information that could be sensitive. Again, LLMs do not have judgment. And so if they do have access to this information, they may expose it in their responses to users, or they may leverage it in some way that is not malicious, but is still damaging to the organization if it's not controlled. So the second area of our data that we need to know about if we're going to allow AI to access it and work on it on our behalf is the sensitivity of the data. And do we know that an agent should have access to a certain level of sensitivity? So an agent, for example, that works for the HR team is going to have access to pretty sensitive information. It's going to have access to employee records. And as long as we know that and that's acceptable and within our policies as an organization, that's okay. Where we have an issue is if the access level of the agent is disparate from what it should be accessing. Lastly is certification. So if you have a data governance process that you've invested in, you also want to know that not only are your human analysts and your human data scientists using data that's been certified by your data governance organization, you want to know that your agents are doing that as well. So this is sort of the third axis that we want to be able to measure our data on as agents are accessing it in order to understand if that agent's actions can be trusted or not. Is it acting on certified data, or is it going and picking up some data that it found in the data lake somewhere? It turns out that it's just some test data that was logged by an engineer. Again, the LLM doesn't know that. It's going to use whatever it finds. So to deal with this, what we've built internally at Bigeye is an AI data gateway. So we have a prototype of this that we've started to interact with and even start to test with some of our customers in a design partner program. But what this does is it wraps the MCP servers, which we just saw in the demo a moment ago, it wraps the MCP servers for each of those underlying data stores and exposes them to the agents as a single interface. So I can take my agent from Copilot or Agentforce or whatever platform I'm using, connect it to the gateway, and through the gateway it gets access to all of those underlying data stores, and it can now start to run queries on them. So this has a couple different advantages. The first is that it makes it easier for me to connect my agents to the data sources because we don't have to do this. We don't have to deal with all these spider webbing point-to-point connections. They just connect to the gateway, and we handle the exposure of the MCP servers underneath. But what it also does is it gives us a bottleneck through which we can monitor what data are those agents accessing. Because if they're all going through our gateway, then we can look at the queries that they're running. We can see exactly what columns they're fetching out of which tables in every single data store, even if they're touching multiple data stores. And then we can overlay that with the metadata that we already collect as a data observability platform about things like the quality of the data, the freshness of the data, even the sensitivity of the data. So putting that all together, we get an architecture like this. So we have Bigeye there in that box in the center, roughly. That is connected to the data stores, and it's monitoring the quality. It's monitoring for the sensitivity of the data. It's also checking which data sets are currently certified or not. It's tracing the data lineage, as I mentioned at the beginning of the talk. And so we have a complete picture of the data pipeline and what's going on with the data inside of it in real time. And then because of the gateway, we can also trace what agents are accessing what data. And because we can put those together, we can now say, this agent accessed this data set, but when it did that, that data set was actually suffering from a huge duplication issue. So it had 5 times as many rows in it for the last 24 hours as it should have. So that would explain why the customer support agent told the customer that their bill was 500 pounds when it actually should have only been 100 pounds because we had a duplication problem in the data set. So we can start to identify these things automatically now because we can intercept the traffic between the agents and the data. And so we call this the AI Trust Platform that we're developing today. And so we view this as the future, which is not leveraging AI inside of the data observability platform, but rather leveraging observability to support AI. We're rolling this out later this year and into next. So today we are previewing this feature with our design partners. So this is a select group of existing Bigeye customers who are prototyping this product with us right now. In Q4, it will expand to also include data sensitivity signals. We intend to move to make this generally available to the public in Q1 of next year. And then the marketplace that you see there on the far right, this is our vision that this system will also be able to take in metadata from other systems, not just from Bigeye, but we'll be able to take in other information from other vendors that you see here at Big Data London. We'd be able to import that information and overlay it with your agent data access patterns. I'd love to talk more about this. You can find me at booth H40. If you want to download Gartner's market guide for data observability platforms, you can scan that QR code there on the left. If you would like to get a demo of Bigeye for data observability at your company, you can scan the QR code at the right. Thank you so much for coming to my talk, and have a great day at Big Data London.